Thank you, and thank you so much for having me. This is a topic that I am always happy to talk about because it's just so increasingly important as AI is adopted, and so we'll talk about that. I'm going to share my screen now. Let's see. We are trying to figure out what to do as far as the questions. So I have some overview of how machine learning works, and it's from an old paper, from a 1996 paper, not my work. If there are questions or if you feel like everybody knows this, just let me know and I'll try to adjust. So again, my name is Lauren Rhue. I'm an assistant professor of information systems at the Robert H. School of Business, which is the University of Maryland. And I'm going to talk about the promise and peril of artificial intelligence and fairness. So there's four basic things I want to talk about. The first is um, what is artificial intelligence machine learning? Um, the second is what is the promise and peril of it, and the promise, the peril, and then the next steps. Um, so to start with, what is machine learning? Um, One definition is the ability to interpret external data correctly, learn from such data, and to use those learnings to achieve specific goals. And I've highlighted a few important parts. One is data, right? Data is the foundation for machine learning, and it's what's going to be used to create these inferences and to create this learning. When you're training a model, of course, you have to have some specific goal in mind, some problem you're trying to address, some target variable you're trying to predict, and often there's some type of flexibility and adaptation over time. Okay. Um, Artificial intelligence, machine learning is being increasingly adopted. I'm sure we've all seen these examples. There's chatbots that are becoming live right now to help customer service. Amazon with logistics, with distribution, with personalized recommendation systems. Facebook has their targeted ad program in which they're taking the data and your interaction with social media and using it to tailor products. ZipRecruiter is being used to find candidates. The criminal justice system, of course, is increasingly using predictive models. Monster with hiring apps. Banks are using it to try to figure out borrowers, to figure out lenders, to provide customer service. Of course, the military is using it as well. And airplanes are also using artificial intelligence. So across the board, we're just seeing machine learning being adopted in all of these different areas, and of course, autonomous vehicles. So, how artificial intelligence works, or machine learning in particular, you're going to collect your data as the basis for the model and train this model to distinguish between different groups. So, again, the figure one is from a 1996 paper about this knowledge and discovery and data mining process. You take your data, and the first thing you're going to do is select the data. Out of the vast array of things that you could look at, what are you trying to look at? And then once you decide that, you pre process it. And of course, this is one of the first places in which people's choices really make a difference. So if you think about how you're going to process the data, if we think about it, let's say with race, there's all these different ways of coding race. Are we going to look at nationality? Are we going to look at intersectionality? Are we like, is Afro Latina going to be coded? How is that going to be coded, right? Biracial, how is that going to be coded? Then we move from pre-processed data into transforming that data. And again, we're seeing ways in which a lot of the choices that people make can then influence what ends up coming out. Then there's the data mining process in which you're choosing your model, you're trying to find these patterns. And the last one is how do you interpret and evaluate those patterns? And once again, how you interpret and evaluate those patterns could have some serious effects, whether good or bad, on the creation of knowledge and on the choices that people make. So that's a 10,000-foot view of how artificial intelligence and machine learning works, what the process is. I want to take you through a very specific kind of toy example. This is from a 2016 paper about how to identify a wolf. So you have this classification task, which is you have a picture. Is it a wolf or is it a husky? And so you're going to have a set of training data. In this case, it's a toy example. You would obviously have more than just four pictures, but you have some pictures of wolves and you have some pictures of huskies. You've labeled them. So we know that the first two pictures are wolves, the second two pictures are huskies. When you put it through your model, it's going to take this training data set and learn. so that when you show a new picture, it's going to be able to say, I think this is a wolf or I think this is a husky. And this is an example of the output. So after you put this through your classification, your classifier, you can say, is this a wolf or is it a husky? And they're all new pictures. And this is great. There's only one mistake. The first three, the top three, they were all correctly predicted, wolf or husky. Only that one on the bottom left was predicted to be a wolf, was actually a husky. So while you might think this is a great model that you have, you realize it's learned an unexpected pattern, that the classifier learns that the snow is the equivalent of wolf. And so it completely disregards the dog's face and says any time that there is snow, it's going to be a wolf. And when you go back and you look at the training data, you realize that every picture of a wolf did in fact have snow. So that's a valid pattern from the training data, but that's not what you want the model to learn. And so I bring this example up because it's so relevant in so many different aspects of machine learning. You have these patterns that exist in the world, and that might not be what you want the model to take from it, but yet it is faithful to the training data. So that's something that we'll be talking about as well. So now that you have this overview, I want to talk a little bit about the promise and the peril. So we'll start with the promise of AI machine learning. And I'm taking this in particular from a perspective of what helps the Black community. Okay, so artificial intelligence machine learning can offset human bias, and that's one aspect as well. It can apply criteria more consistently. So there is a few issues, right, where you might have exceptions that are being made or implicit bias. And when this criteria is applied more consistently, you'll see a increase in inclusivity. It can also remove racial attributes, enable auditing to ensure non-discriminatory behavior, and identify opportunities for traditionally overlooked people. So I'm going to talk a little bit about those. First is human bias. You've probably heard of this paper that looked at resume callbacks and found that resumes, identical resumes, but if a resume had an identifiably Black name, it would receive fewer callbacks than the same exact resume with a white name. And now there's predictive software that can remove racial attributes. So it can automatically remove names and try to anonymize it. It can remove, let's say, HBCU names that can then trigger people to say, HR managers or hiring folks to say, we don't want to give that person a call back. Another example is Airbnb while Black, or some of the digital platforms in which there's bias. You can use predictive models to identify anomalies and check for discrimination, saying, wait a second, it's really strange that this particular person has never let a person of color stay at their Airbnb. So that's just an example of how you can use and how models can be developed in such a way that will identify anomalies, check for discrimination, and create more inclusive platforms. In my work, I've also looked at predictive models for recommendations or for project promotion. So we're seeing that if you use a model to try to figure out which projects to promote, you end up with more inclusivity. So if we're using people to make that choice, about 6% of Black projects get recommended. But if we use a predictive model, we see 7%. And if we use a predictive model that's fair aware, we get almost a 10% project promotion rate. So this really, to me, shows that, again, this idea of having something that can be objective, that can disregard criteria that we want them to disregard, can lead to increased inclusivity. Another example is financial opportunities. So lenders charge otherwise equivalent Latinx and African American borrowers higher rates for mortgages, whether it's purchases or refinancing, and that can have a huge cost, right? That's about $765 million yearly. But algorithmic lenders have a lower rate disparity and show no discrimination in rejection rates. And again, part of the reason they think that is you're having this criteria applied much more uniformly. And so in that sense, things that shouldn't be relevant to whether or not you're able to lend, whether you're able to repay your mortgage, aren't being considered. Whereas people can be more subjective, they're not going to be as consistent, and that can end up harming us. Okay. So I'm going to take a brief pause here before I talk about perils. Because are there any questions? I see there's not much in the chat, and it's easier for me if I can get a sense of where this audience is. I also talk pretty fast, I know. Okay, so if you do have any questions, again, feel free to post something in the chat, or you can unmute and say something. So some of the perils of artificial intelligence, of course, are algorithmic bias. Artificial intelligence, big data can produce this disparate impact for women, people of color, other traditionally disadvantaged groups. And again, that's because AI is trained on existing data. The resulting models are going to reflect societal bias, and that's going to be problematic, of course, and especially if they're not trained in such a way to consider algorithmic bias and how to offset algorithmic bias. There's all sorts of examples of this. We have accurate but yet unwanted patterns. So automated hiring, one of the challenges there is it's trained off of who are the people who excel. So for example, if you're in finance and all of your superstars are white men, that's what you're going to see. That's what the model is going to try to find. It's going to be really difficult to train out the bias when that's a systemic issue. Another example is a wrongfully accused man in the Detroit Police Department sues over false facial recognition match. So the idea that there's different patterns of accuracy. Many of the facial identification models, so models in which they try to identify whether it's a picture of you, perform worse on people of color. So what that means is that if you have that being used by a police department, you're more likely to get a wrongful match. A beauty contest was judged by AI and robots didn't like dark skin. So again, that's colorism patterns, which I'll talk a little bit more about. Also in healthcare, there is an algorithm widely used by US hospitals that was systematically discriminating against Black people. It would, because it used spend as a marker for illness, what it found is that essentially Black folks in particular are less likely to go to hospitals. They're less likely to spend, so they have to be sicker. So the way in which the choices that they made ended up discriminating against us. And then, of course, there's risk scores in the criminal justice system and Amazon's tool, internal recruiting tool, that was biased against women. So I'm going to give you an example of something that I've looked at in particular, predicting labels. And so this is an example of a lipstick advertisement. It's the same shade on 3 different tones. And when I looked at Amazon recognition to see what the labels would be, it correctly identified the label on the lightest skin face, but it incorrectly identified the label on the 2 darker skin complexions. So we have ketchup for both the bottom 2. And that's again going to be an issue when you have predictive labeling of pictures, right? And we've seen other examples as well where it's not able to recognize something that should be recognizable. Another example is auditing emotion recognition AI for fairness. So looking at bias in the emotion recognition. How I did it is I used image data sets. In this case, this is a basketball data set. I compared emotion scores across these different AI models and found that there was, in fact, not shocking discrimination. So negative emotions such as fear, anger, surprise were pretty consistently higher for Black faces. And here's an example of that. So here's Paul Millsap, he's smiling. Microsoft did not show any anger, but one of the more widely used ones showed that he was angry 8.5 out of 10. And even Amazon recognition showed that the anger score was twice as high as the happy score, right? And that's something that if you're looking at his face, it's obviously not true. And so there are examples like that that can happen somewhat consistently. So there are these evidence of disparities, and the question is, how do you train them out? Part of it has to do with the data set choice. Part of it has to do with awareness as well. Another example is predicting beauty. So there are, in fact, models that exist entirely to predict beauty. I was stunned when I found this out. And so I immediately went to looking to try to understand what they were trying to predict. So this, of course, is Beyonce. And I looked at pictures of her with blonde hair and pictures of her with brown hair, lighter, darker. And the results are not in any way surprising, right? This is examples of colorism. We have she's 75% beautiful out of 100 on the left, but when her skin is lighter and she has blonde hair, she's 85%, 87% beautiful on the right. I did another example with a beauty with Miss Missouri, who is Miss Missouri Jennifer Davis, and I just lightened her skin, so nothing else has different, and we can see that on the right, she again is slightly more attractive according to these models. Now, the question might be, so what? Well, the problem is that it's consistent across different models. So this is an example of a tool to help you see if your pictures are Instagrammable, if they're well done pictures. So again, the picture on the left, which was the darker picture, is 57%. So it's normal. But the one on the right, the artificially lightened one, is 72% good, right? And so that obviously shouldn't be, right? That's completely unacceptable. It's also, we're noticing that for product and cosmetic surgery recommendations. So this is again an AI that's out there. The original picture is more likely to receive recommendation for bags under the eyes, so 11 percentage points more likely to receive that, more likely to receive a recommendation related to having a big nose, and then more likely to receive one for having big lips. So obviously, this is a problem, right? And this is an example of peril because people don't necessarily realize it, they're not talking about it or thinking about it in the context of developing these particular algorithms. So we have to be very careful about what we use machine learning for, why we use it, who's developing it, and how we deploy it in the world. Okay. So that brings me to some of the next steps, right? We've talked about some of the promise of it, which are ways in which we can use artificial intelligence and machine learning to audit, to ensure non-discriminatory behavior, to anonymize where appropriate, but then also the perils, particularly in subjective situations. If we're training a model based off of societal bias, we will reproduce societal bias. Organizations are going to continue to adopt artificial intelligence and machine learning for monitoring, for customer satisfaction, for employee behaviors, student academic integrity. We didn't even talk about threat assessment or the criminal justice system. They're also still using it for hiring. And particularly interesting are the new business models, like a comedy club that has a per laugh business model where you're using machine learning to decide if the person has laughed, and then you charge them on a per laugh basis, which has happened in Spain. And then predictive writing tools is another example. Tech companies are taking more responsibility, as well they should, and I think this is where a lot of it lies. Tech companies reconsidering their sales. So IBM discontinued its its emotion recognition system, I believe. Amazon announced a 1-year freeze on the police use of recognition, and same thing with Microsoft. It halted its use of facial recognition to police. So they're taking some responsibility, but it's really about these organizational choices that are key. So organizations should audit their machine learning models for bias and then use them also to see if there's biased behavior, right? So use it to monitor decisions to reduce bias, and also create processes that keep humans in the loop. Something like the emotion recognition, right? If I look at that, if I look at Paul Millsap's face, I can see that he's smiling. And you can't have, particularly in some of these business contexts, times in which you're letting a model run away with it, because sometimes they can't see the bias, and of course we can. And of course, governments can increase regulation, and they can decrease the use of these products in uncertain environments, because that's when you're more likely to see this type of bias emerge. And that's it. That's all I have, but I'm happy to talk and answer any questions that you may have.
Thank you, Dr. Rhue. There are a couple of questions in the chat. Taylor asked, what was the difference between the ALML and the FAIR AI/ML models?
Um, okay, great. So I didn't talk about fairness aware machine learning, and it's this development in which you're training a classifier to consider disparities between groups. And so you have to define what it means to be fair, which is a really fascinating and whole other issue. But if you want to train the model to consider whether or not it has disparities between groups. And so when I used that, it then considers, hey, I should try to be fair, and then it produces a more fair aware outcome. What's interesting though is that it's only really useful in times where you have a great disparity. If it's something like you want to bump up something that's already at, like, let's say 70% and you want to move it to 80%, it's not the best there. But I hope that answers your question.
And then there was another from Frederick.
Okay. So that is an excellent question. It has to do with the representativeness of the data set. And so when we collect data, there tends to be some type of a bias in it. So for example, I really like this example of mugs. When people take pictures of mugs, they're more likely to put the handle on the right-hand side because people tend to be right-handed. So if you have a picture of different mugs, you almost always have the handle on the right. A model is going to learn that a handle with the mug on the left is not actually a mug. And that doesn't I mean, that we know that, of course, it doesn't matter if the handle's on the right or the left, it's still a mug, but a model is not going to learn that. So it has to be as representative as possible. You have to show huskies in the snow, and you have to show huskies in grass, and huskies in a house, and huskies in all of these different places, and then wolves in all of those same environments. Wolves in grass, wolves in snow, wolves, and so that way it'll focus in on the face and use the face to tell huskies and wolves apart, and not the environment itself. Okay. And we see that too with a lot of the computer vision issues, right? Part of the reason why the accuracy is worse for Black folks is we're not in the training data. If you're in the training data, and people like people from all over, right? Not just like a handful of Black people, but a lot of Black people, then that's when you would see the accuracy much improve a lot. But unfortunately, we're not always considered. So another example that recently came out is, I think Google has um, a new skin algorithm that's supposed to help identify cancer. But I noticed that it's not for, yeah, exactly. We're not there, and it significantly affects outcomes. Um, and so sometimes they'll say explicitly we're not in the training data, but that's really obviously a shame, because anytime that Google deploys a model, it's going to have just this huge impact, and you have to be very thoughtful about who's included. Yep. So any other questions?
Well, I actually have a question, and it's related to, I guess, auditing. And the question is about auditing the input data and auditing the models. Basically, are there general ways that you can check, or is it like on a project by project basis that you would need to check the input data to make sure that, whatever it is that you're building a model for, the data is representing, or the data will be representative?
Yeah, so it's usually on a project by project basis, and it's cutting the data in different ways and seeing the number of people that are represented. One of the big challenges is this tension between being representativeness of the situation and um, being representativeness of the future that you want. So, for example, in hiring, right? If all of your superstars look one way, and let's say they've gone to Ivy League schools, and they've all joined the same particular frat, and they all wear their hair a certain way, what have you. If you have a video screening tool that is going to try to have people, it's going to try to screen people, they're going to use your faithfully represented set of superstars. And I think that's one of the challenges, is how do you then find somebody who would have been good but was never hired? And I don't think there's a good answer for that yet.
Got it. And so then I guess it's more helpful to audit the models than actually audit what's going into what the models are being built from off of, rather.
It's useful to audit the models as well, but this might be a case where you say we need to think more creatively about how we get new people through the door.